last class I was discussing about the model number 1 with introduction. We give it a beautiful summary of how it starts with a DBMS and what are the model 1 contains. So how the introduction goes with the architecture that we define. Then we comes with the ER diagram, where I told the DBMS goes with a diagrammatic representation that is called an ER diagram. Now I want to move to model number 2, which tells that a relation model I want to speak about. I want to speak about a relation model, where relation model talks about tables in a DBMS. Tells about tables in a DBMS. Such a beautiful thing as to go with what I call as a tables wise. So diagrammatics comes with the tables. Later on tables on we can go for queries. That's the beauty that given in course number what is called model number 2, where we talks about relation model with the tables for a queries like SQL and a relational algebra. That what want to speak about model number 2. Okay, model number 2. So before going this diagram to and tables, I want to shift the diagram to tables. I want to build on this. That's what my introduction goes with, an ER mapping to ER diagram to ER mapping to table. So ER mapping to tables. Okay. So ER mapping to tables. I need to go up. Because tables goes with the integration model, where the diagrammatic model 1. I want to jump to model 2 with the diagram to tables. Okay, that's called an ER mapping to tables. A ER diagram to tables that we want to speak about. Okay, the first one is in one-to-one or a many-to-one. So let's go with many-to-one. Later part we go to one-to-one. Okay. So many-to-one relationship. So many-to-one relationship. Okay, many-to-one relationship to table. So many-to-one relationship to table. So first step I'm going to tell that a many-to-one relationship to the diagrammatic. So I will take a company database as an example way. Take a diagram of company database to convert to table. So here I am taking example as a company database to match the ER diagram can be converted to tables. Okay. So here the things is we had a table called employee or a diagram called employee with entity that is SSN as a key that defines with the name. Then I have age to define with date of birth, with age to define with the date of birth. Then I have address. Okay. Then I have address. So employee with department. Okay. Employee with department, where D number speaks about a key. It's called a key for a entity that is called department. Key is department number. And department number with department name, where employee works for department. So many employees work for one department. So many employees work for one department. I told many-to-one relationship need to convert to table. I told many-to-one relationship need to be converted to table. So in this scenario of diagram of many employees working for one department, so here you want to build a table called employee, because as a many side you need to give importance for many side. So many-to-one relationship, here you want to give importance of many side, that is called employee. Employee must include all the attributes of employee and comes with a key of department table. Where I have given importance for employee type and taken a key from one side, that is department. So here employee, I built a table called employee with SSN, name. So include all attributes, because I given importance for many side. I given importance for many side. So include all the attributes of this and go for including key of a department table. Include the key of a department table. So name. So here I go with the name as with address, age, then include department number. Then includes department number. Then includes an department number. So you can say that. So I have seen that employee is SSN as a key containing all the attributes of this side because of it many. So I want to, in a many to one relationship, I want to give importance for many side. So I am giving importance for many side which has total participation on both the side. So many importance I want to give it for M side. Include all the attributes of employee and comes with department number from department table. Comes with department number with a department table. Include that attribute as a key because define a key. So department number is a key. Take a department number key and build a table called employee because of I given many side as importance and key taken a key from department table. Okay. So this is many to one relationship. This many to one relationship. So then I need to go. With one-to-one relationship. One-to-one relationship. Convert to table. Convert to an table. Okay. So then I want to one-to-one. So this one-to-one relationship between the employee and a department that comes with like this. So employee manages. Employee manages department. So one employee which has partial side because it was contain many. Now I am taking only one employee as I told in the previous class that there is a partial participation. There is a partial participation in the pick many to one. So there is many employees. I am picking one employee which is called as a partial because there is no participation of all the employees, right? That's what I want to pick, only one employee from many side. So I am picking one employee from many side. This is partial participation with there is only one department that is considered in a ER diagram. It's only one department that we consider. That's what I given one. Okay. So it has one employee manages one department. As I told, there is one HOD in the department. So one HOD maintains the entire department, which is an employee become HOD, which is picking that one. That's what is partial. Manages one department. Okay. So here write a table called department. So include all the attributes of department table. That is department number with department name and include a key of the employed entity, that is SSN. So because of total participation in a one-to-one relationship, I am giving importance for department side where include all the attributes of department side and take a key from employee table, that is SSN. I made a table called department. Right? So such a beautiful things we done for one-to-one and one-to-many relationship. One-to-one and a one-to-many relationship that we made it, right? So then I'll go because many to one we done. So then we done with a one-to-one. So then I will go with one-to-many relationship, or I want to go with because one-to-many relationship because many to one we done it. So now we will go to one-to-many relationship. One-to-many relationship. So one-to-many relationship where it speaks like this. So next table is I want to define. So here department. So department project. So department project. So department as department number, department name. Okay, here we have a project number, project name and project location, project location. Okay, so department handles or controls the project, handles or control the project, where one department, as I told, there is only one department in a previous year diagram. It is one department manages or handles many projects, manages or handles many projects. As I told previously that many to one side, where I told that many side you want to give importance, right? You want to give importance for many side. So it is as include all the attributes of this and go for taking and key from department entity, key from an department entity. So here if I consider a table called project, a table called project, a table called project, a table called project with P number, P name, P location and D number, and D number, and P number, P location, P name, and I am talking about department number. So it's include key as a P number, key as a D number. So with a D number as a foreign key, with a D number as a foreign key for a table called project, for a table called project, where a department handles many projects. So I want to give importance for, the project entity. So I include given importance for project entity what and many attributes that is contain P number, P name and P location. What department number as a primary key that belong to entity called department. I include that and made a table called project with a P number, P name and P location, and with a department number as a foreign key. So this is the way of conversion of one to many. This is the conversion of one to many relationship, one to many relationship to a table, So next I want to go with many to many. I want to go with many to many relationship. I want to go with many to many relationship. Okay, so there I speak like this. So many to many we have relationship, right? So that is employee, So as I told, employees, SSN, name, address, each, address and a derived attribute, that is each. Okay, that is each. Okay, so then it goes with project. It goes with and project, right? Project as I told previously, P number, P name, P number, P name and P location. P location, that is employee works on, employee works on for number of hours. Many employees works on number of hours on many projects. That is MS to N, which is total participation on a both the side. Total participation on a both the side, right? That's what we done. So employees, many employees working on many projects. Number of hours you want to specify an attribute for relationship, where many employees works on many projects with a number of hours to be specified. Where employee with SSN, project with a P number to be specified. So my next job is to I want to convert many to many relationship to the table, many to many to table, right? So now I'll make a table called works on. Okay, because the relationship is works on. So because it's an entirely different relationship when you compare to one, there was a giving importance for one side, and many to one we are giving importance for other type. One to one I was giving in relationship for importance for total participation. Now I comes up with many to many. I want to give importance for both the side. I want to give importance for both the side. So I need to give importance for both the side, right? So that's the question arises in my mind. What I want to do it out, right? So employee works on project. So many employees works on many projects for number of hours. That's what I made a table called works on with relation specified, where I take a key from SSN, key from project, that is key from project table, that is P number, key from employee table, that is SSN, what number of hours to be specified, with number of hours to be specified for a particular project where the employee is working on, right? So SSN is another type of key. SSN is a key, and P number is a other key attribute that we taken from project. So both are key, which may be called as composite key, which I will be discussing next session, right? Which I will be discussing next session about the keys constant that will be specified in a table called relation database, right? So works on SSN. P number is a composite key, a relation between from one-to-one relationship to the table, one-to-one relationship to the table that I want built at, right? I have to be built at such a wonderful table from one-to-one relationship, okay? So we done with one-to-many, many-to-one, one-to-one, and many-to-many. So now we've done all the relationship constants that define. We're done with all this one to conversion of a relationship to the tables. So now I'll go with a weak entity. I'll go with a weak entity to the table. Weak entity to the table that I want to be specified. Okay. So here, and weak entity to the table. Weak entity to the table that I want to convert. Okay. I want to convert it out, right? So here, employee, here the employee. So employee as SSN, employee as a name, right? So as I told you, we have attributes of employee, that is address. Okay. So now, as I told, there's a weak entity, right? So employee dependents, employee as dependents, that is the weak entity that we define with the partial key, that is dependent name, okay. Then there is dependent relationship that you want to define, okay, with the each, with the age as a attribute, So employee, one employee, as I told, as many dependents, So one employee has many dependents, is a weak entity, contain a key called partial key. So now what is my job? As I told, this one-to-one, one-to-many, many-to-one, and we're done with the many-to-many. So now I want to convert weak entity to the table, So here we want to give importance for weak entity attributes and include a key of the dependent attribute, dependent table, that is called employee, So employee has dependents, so include all the attributes of weak entity and take a key from that the entity which is on dependent, that is, so depends or depend on employee. So employee has dependents, as I told, in any of insurance, the company if I are working on, so they will search for my dependents through my SSN. That's what include all the attributes of dependents and take a key from the entity which has dependency. So here the employee which has relationship with dependents, so include all the attributes of dependents and take a key from employee table, that is SSN. So I made a table called dependents. I made a table called dependents. Okay, I made a table called dependents, includes dependent relationship, dependent name, then each, then SSN. Okay, the partial key that we had, dependent name with the foreign key SSN, with the foreign key SSN which we taken from employee table, which we taken from an employee table, which we taken from an employee table. So here you can see the dependence is a weak entity that we got from employee, that we got from employees. So that's what I include all the attributes of dependence with the key called SSN. Let's make weak entity to the table. So whenever you find real-time application where you find weak entity, so take all the bit of weak entity and all the attributes of weak entity and take a employee, take a depends, which are the entities that depend on weak entity. Consider that and take a key of that and make a table called weak entity table with all the attributes with entity of dependency, that is employer. If I consider any real-time application like bank, there may be a find payment as means loan as a payments, where payments has been told that weak entity include all the attributes of payment and take a loan number, so that based on this loan number I can identify how many payments have been done, right? How many payments have been done. So here I made a dependence, include all the attributes of dependent. So based on SSN I identify the depends information that will be identified. That's what weak entities become a table. Weak entity become a table with support of strong entity, that is called employee. That is called an employee. That is called an employee. Okay. So this is way of conversion of weak entity to the table. Weak entity to the table. So next, multivariate to the table. Multivariate to the table. So because multivariate is a variety of relationship that concerns, right? Multivariate to the table. So I want to convert multivariate relationship to the tables. So weak entity, we done it. We done the relationship. Now I am going to the multivariate to the tables. So here we have a multivariate relationship, that is what it contains. So we have department table. We have a department table. So we have department table. We have a department table. So department with department number, department name and department location and department location, right? So department location is a multivariate attribute. It's a multivariate attribute, right? So it's a multivariate attribute. So I want to convert this to table. So I'll name a table with a relation name, that is department location. Take to department location. Department location as a table. Department location as a table includes what is simple, that is department number. Take a key of this, because department location is a multivariate attribute. Take a key of this. That is department number with department location, which is multivariate attribute. So I made a table called department location containing a key of this particular table which contain multivariate attributes, that is department, that is which contain department location, that is contained by department. So department locations table containing department number as a key, department number as a key with department number as a key, and goes with department location as a multivariate attribute. So here we made a beautiful table for multivariate attribute contain key and a attribute of multivariate, that is department location. So department number, department location makes a table called department location. So this is what you call as multivariate attribute to the table. This is what you call as multivariate attribute to the table. Okay. So this is again we come with multivariate. So now I'll make it to ternary relationship. As I told, ternary relationship as a table. Ternary relation to the table. So ternary relationship to the table. Ternary relationship to the table. So next question is how to do this, because we come up by coming up from one-to-one relationship, then I comes with what I call multivariate weak entity. Now making ternary. Ternary is three entities. More than two it become ternary. So only if contain one or two with entities that become binary relationship. When you more than 2, it's called ternary relationship, right? So here I had a table or entity that is called supplier with supplier ID, supplier name. Here we had supplier supplies products to the project. So supplier supplies products to the project, that is project number, project name, right? Project name. Then we have products with the PPID, product ID, okay, because this is a project number, it's a product ID with product type that you want to define, okay, that is defined, okay. So now I want to build a relationship. As you know, there is a coordinate ratio which cannot be applied for ternary relationship. So you cannot apply coordinate ratio that is 1:1, 1:many, many. You cannot apply for a ternary relationship. You cannot apply for a ternary relationship. That's what I may not able to apply for coordinate ratio for ternary relationship. With the total participation constraints cannot be applied. Participation constraints cannot be applied for ternary relationship. Cannot be applied for an ternary relationship. Okay. So here you like this. This is a table I have built it with supplier supplies. So what you can as so date, which date he published, which date is supplied the products to the project, right? So supplier supplies products to the project. So supplier supply products to the project. That is be done, right? That's what we done in ternary relationship. When I was talking about teacher subjects to students, a teacher subject to students. That was what was talking about ternary relationship in a previous my classes, right? So here I'm talking about an supplier supplies products to project. So now my job is to convert this to a beautiful table where I talk this table as like this. So include the key of supplier table, that is SID. Then include a key of products, that is PPID. Okay, that is PPID. So products ID that is included as a part of this entity, this products. Then I want to include the project key, that is project number, okay. So then I need to go with include an attribute of relation that is contain date, okay, that is contain date. So you can see that ternary relationship where it contain a key of suppliers, contain a key of products, contain a key of project, that is P number, that is PPID, that is product ID. Then you have supplier ID. Include all the IDs with relationship contains date have been added here. So this makes a ternary relationship to the table, called supplier. A table called supplier contains a key from supplier ID, key from products, key from project, and a attribute from a relationship table. That is date. You have been included, and we converted a ternary relationship to the tables. So if you done any ternary relationship in a AR diagram, this is the way of conversion to this diagram to table, So you may find the ternary relationship in your project whenever you go to project, because you have a mini project, right? As a syllabus of concern of 15 CS, 18 CS, 53 as a there is a lab called, with the lab there is a mini project where you want to do it out. You want to take real-time application. In real-time application, you want to write a ER diagram. For ER diagram, you want to convert this ER diagram to tables. This is the procedure you want to follow. You can't go direct a table. Table is there. So this table is we have, right? You cannot take that. You're required to specify the real-time application, what you people are taking up, Then you want to come with a error diagram. After error diagram, you want to convert this to tables. Based on these tables, you want to build a beautiful front end and back end tools. So then you want to go with the real-time application that requireable. Okay. So you want to convert this error diagram to tables. So this is the way of conversion of an internal relationship to the tables. Okay. So then I'll move to what I call as a generalization to the table. I'll move to and generalization to the table. A generalization to the table. Generalization to the table. So as I told, generalization has variety of types. So there is a lot of things to be considered when you go for terminal relationship. Okay. When you go for generalization, there is, I told, entity can be splitted. Based on generalization. So here we have accounts. Right? We have accounts. What? Account number. It's a key. Account number is a key. So account number is a key with a date to be specified. Which date you created? That account. Because account number is created some date, right? That's what. So you want to think about accounts which date is being created with the account number. So I can split this. So you have a saving account, right? Saving account as how much amount you have considered for saving account. How much amount you have invested for savings. It's a savings, right? How much amount has been updated in your bank database, right? So accounts has been split into other entity that is called savings account with amount as a attributes for saving account. Then we have current account, where it specifies current amount that has. Amount with a C is specify. I'll specify is amount C. So because current account, how much amount it has. Then I comes with fixed deposit. So how much amount that has been fixed deposit account that has been contained. So here I specify F amount. Okay. So here we take an entity called accounts, include attributes for accounts. Then I use a generalization symbol that is represented with thus. Then I comes with saving accounts, current account, and a fixed deposit account. If I consider employee table, so then I think about employee with a teaching or non-teaching, or employee with a full-time or a part-time, right? So here we take an accounts as an example. So for bank database, accounts with the account number, date, and saving account, current account, and fixed deposit account with very different types of attributes, right? So first table that contain accounts, as a table name with account number as a key and a date as a attribute, This is one table that has been defined. First table, initially the first table I mean define here. Okay. So then there is savings is a table. Saving as a table contains amount of attribute that it contains, amount of attribute that belong to saving account, that is amount with a super entity, it's a sub entities, it's a super class, it's subclasses. So here the super class is accounts containing account number as a key. So include this account number to this subclass, that is saving accounts. You can add it out, that is account number. So superclass, subclasses, when you create a subclass table, include a superclass key, that is account number, to the subclass. So amount, account number, savings. Account number, savings have been added to a table called savings. Then there is, I want to create a table current account, right? So current account table need to be created. So I'll create here itself. So current account as amount C with account number as a super keys. That's what include current account is a table name. Current account is a table name, includes current amount with account number as a super class key, that is account number. Okay. Then fixed deposit. So we have a fixed deposit with, so we have to specify F amount and account number. So you can say that generalization specify with superclass and subclasses for an entity. So here I specify the accounts table with account table. Then I go for subclasses, that is saving accounts, current account, fixed deposit account, include attributes of subclasses with a super key, what is called superclass that is contain savings with account number as a key. Add for all the subclasses, that is savings as a amount with account number, account as account number, so current as current amount with account number, so fixed as fixed amount with the account number. So this is the way of generalization conversion to the table. So this is the wonderful thing that we come with conversion of ER mapping to an table. Conversion to the ER mapping to table. Such a wonderful have been built. So such a wonderful things have been built, right? So this is the way of conversion. To the tables, because as I seen any we write lot of diagrams. As I told, I was done with the 3 or 4 ER diagrams for your classes, right? So there I was thinking about hospital database, bank database, employee database I was talking about, right? And written movie database. So you can take a ER diagram for such a things as, and conversion is a table. Later part tables can go for insertion of some tuples and go for queries with the specified database. So here further when I go into handle the relation model, what the things is, I'll use company database as one of the perfect example for doing all the type of examples with the queries, so that the flow goes in a way of understandable. Understandable can be done very easily for a company database. Okay. So thank you. Next class I will think about this tables. Go for relational database. Okay. Thank you so much.